Dear participants, welcome to Ninth International Symposium on Multidisciplinary Studies and Innovative Technologies. The conference is supported by IEEE Turkey section and also supported by Tokat Gazi Osman Paşa University. We are in session 8.1 now, and we have 8 papers to be presented in this session. Each participant will have 10 minutes to present their studies. The title of the first paper is Designing an Android application for accelerating food delivery pickups. I think the author is not here. The title of the other paper is The Need for a Compact, User-Friendly Battery Simulator for Research. You can share your screen.
Hello. Should I start by sharing?
Yes, you can share your screen.
Okay, thank you. Let me give me.
Okay.
Yes, I shared it, I guess.
Okay,
Can you see it?
we can see him. You can start.
Hello, everyone. The paper today I'm going to present you the paper, The Need for a Compact and User-Friendly Battery Simulator for Research. I'm Ömer Arda Özdemir. The content of this presentation will be the introduction and then we go into the battery simulators, and then the operational principles of battery simulators, and then the battery simulators in the market, and then the UBS 30-20-10, and then the conclusion. Why battery simulators matters? Because with battery simulators, fast charge discharge cycles in development can be accelerated. What I mean by that is we can accelerate the development cycle of devices with by charging and discharging them, and take their responses. The fault scenarios of these devices can be observed without exposing any person to live cell hazards, and the calibrated limits and feedback yield consistent results for repeatability, minimize cell consumption, and device wear in lab time will result in cost-effective testing. What is a battery simulator? They are programmable source and sink that regulates the terminal voltage and current to emulate a cell or pack of cells while sourcing or absorbing power. They reproduce OCV and SOC curves for dynamic internal resistance, temperature effects, transient or standard constant current or constant voltage profiles. The voltage current temperature limits keeps the device under duty safe from open or short voltage or currents. Control system accepts analog or digital commands and returns the calibrated VIT results for repeatable tests. The history of these devices they started in 50s with NASA engineers adopting simulators to test the contingencies safely without the live cell hazards I mentioned before. In 70s, they released the first practical design of a battery simulator, and in 2009, the research on modular or scalable simulator systems enters the literature, and 2010s and 20s, precise lab units, high power regenerative racks, and HIL cell emulators become standard. The different sectors, they are used in many different sectors. Some of them are phone battery, consumers and mobile electronics, IoT or embedded systems, small robotics and mechatronics, drones and lighting tools, educational or research laboratories. In simple in simple way, these simulators are consists of different op-amps and reference circuits. They compare these voltages and currents, and they deliver the other values. They are shown in the simplified network and resistor of battery simulator circuits. There are many different simulators in the market. One of them is Panvatron UBS 302010, which is the new kid in the block, and we will delve into it later. Voltage limits is 14 volts plus and minus. The source or sink current of its one hand have 1.5 amperes. It is controlled via a microcontroller with PWM. You don't need a fixed hardware. I With a fixed hardware to control it. You can use any more microcontroller to use it. And the resolution is defined by user. And with good calibration, you can increase its accuracy. The Kitly 2281S is 20 volt max and with max source current of 6 amperes and maximum sink current of 1 amperes. It is programmed through SCPI commands and interfaced with USB, LAN, or GBIP. It is high precision band. It is made for high precision bench applications. And there are how can I say, heavy industrial simulators in the market, such as the Chroma 7020 regenerative battery pack system. It is regenerative power usage, allows its high power to be sustainable. And there are the Eco EE3000 with these 12 independent channels, each offering up to plus or minus 5 volts and 0.5 amperes. The UBS 3020, as I said before, is the new kid on the block. It has 14 volts and 1.5 ampere operating limits for simulations or emulations, or you can use it as a programmable power supply or as an electronic load. The charger emulation modes consists of constant current, constant voltage, or by using its pins, you can make it like a constant resistance or constant power. Discharge and device power mode acts as a power of. I didn't mean that. Let me get that there. Okay. Where was I? Discharge or power device power mode acts as a power supply. You can set the current pin as 0, and then you can use the voltage out pin with 1:6 ratio and use it as a power supply. And these are its functions. As you can see, it has 10 different pins, and you can give control inputs with ref V, ref C, and enable disable pin. You can use the enable disable pin with high logic. You can use either 3.3 or 5 volts, depending on the microcontroller you use. And when you set it to 0, it disables and shuts the whole system down. The feedback outputs you can get with the constant current pin 3, CD pin 6, VBAT or TBAT pins. VBAT is the virtual battery voltage feedback. It has 1:6 ratio again. You can use it to 0 to 2.34 volts again. TBAT pin is the virtual battery temperature. You can set its temperature as when it will stop. It can support 14 volts and 1.5 amperes, and you can make any combinations in these limits. So it supports any battery in the limits of 14 volts and 1.5 amperes. The cool principle is the novelty of this novel part of this battery simulator. It has no embedded controller inside. It uses the vendor protocol, or it doesn't use any vendor protocol, or makes the user use its preferred language and toolchain. With this system, the resolution and algorithm is user defined, and they can use in any way they want. The interface is pretty simple. You set the voltage current from your microcontroller. Use the enable disable pin to start or reset the whole system. And then you have to, there are 3 different ground pins to ease of use. And you can plot the voltage, current, and temperature over time for repeatable tests and test its results. In conclusion, battery simulators reduces the risks and time for a better development. And UBS 3020 delivers a compact, cost-effective solution for these applications. And the cool principle is a freedom. How can I say, is a freedom principle. So you can use anything in any way. The simple pinouts makes it quite user-friendly. With its compact nature, you can use it in laboratories and carry it around. This device doesn't give you the raw power of the other devices that I mentioned, but it is good for research and development applications. Thank you for listening.
Okay, thank you for your presentation. Are there any questions? Okay, let's go with the next paper. The title of the paper is Energy Efficiency Maximization with Dynamic Reflection Coefficient-Based Physical Layer Security, a Symbiotic Approach for Cellular Networks. You can share your screen.
Okay. 1 minute. Can you see my presentation?
Yes, you can start.
Okay, thank you. Hello. My name is Muhammed Yusuf. I am an assistant professor at Hittat University. I work on next generation communication system, for example, 6th generation. I will present my work on energy efficiency in symbiotic radio networks. Why symbiotic radio in 6th generation? 6th generation needs reliable, low latency, and energy efficient communication for many connected devices. Symbiotic radio lets low power devices use the existing network, for example, Wi-Fi bus station or FM station or TV tower, and spectrum in a smart and efficient way. Devices can backscatter signals to send data and harvest energy at the same time, reducing hardware and spectrum cost. Symbiotic radio system face security risks from eavesdropping and interference attacks. Classical cryptography is not suitable because symbiotic radio devices have very limited energy and processing power. Physical layer security gives a light and energy-friendly protection method by keeping the legitimate channel stronger than the eavesdropper. In sixth generation IoT networks, the key question is not only secure data rate, but also how many secure bits can be sent per joule of energy. Energy efficiency has become an indispensable performance metric for secure communications. The proposed system allows devices to harvest energy, backscatter signals, and actively transmit using dynamic reflection coefficient. The reflection coefficient controls reflected power, stored energy, and interference at both the legitimate receiver and the eavesdropper. Time division and reflection create a multi-dimensional optimization space where energy, security, and data rate strongly interact. Changing jammer signal power, reflection level, or harvesting time affects both energy efficiency and secrecy performance. The goal is to maximize energy efficient under secrecy and quality of service constraints in cellular symbiotic radio networks. Unlike previous studies, this work considers both secure transmission and the energy cost of achieving secrecy. The gateway receives the symbiotic signals while an eavesdropper tries to intercept them at the same time. Devices can harvest ambient signal, for example, Wi-Fi signals, backscatter data, or transmit actively, making the optimization holistic and tightly coupled. We proposed an energy-efficient and secure optimization framework using dynamic reflection and time controller. Our model shows how reflection, jammer power, and time sharing affect energy harvest and data rates. Results show that low to moderate jammer power gives the highest energy efficiency. Reflection and time intervals must be adjusted according to quality of service and power thresholds. System model. In the system, we have two users, two relays, bus station, two jammers, and two eavesdroppers. The communication takes place in 3 times slots. Tau sub 1 for the first cell, left cell, tau sub 2 for the second cell, and tau sub 3 when both relays send data to the gateway. There is, as you can see, there is no direct link between the users and the gateway. In tau 1, user 1 forwards the transmitter's information to the relay 1. In the same way, in tau 2, user 2 does the same and sends the information to relay 2. During tau 1 and tau 2, both users also have the transmitter by supporting its data transfer process. Thus, this is symbiotic communication networks. In tau 3, both relays transmit their own information to the gateway at the same time, simultaneously. The total frame time is fixed, so tau 1 plus tau 2 plus tau 3 is equal to 1. Okay, next slide. Program formulation, the number of bits per bandwidth transmitted to the gateway via relays, relay 1 and relay 2, in tau 1 and tau 2 time intervals is expressed as follows in equation 1. In this equation, the transmit power of base station is donated by PT, and alpha sub U1 is backscatter reflection coefficient of user 1. In the same way, alpha U2 is backscatter reflection coefficient of user 2. This equation is channel canal capacity formula. The number of bits transmitted simultaneously by the relays to the gateway in the tau3 time interval is expressed as follows. And the energy harvested by the relays 1 and relays 2 is given as follows in 3, 4, and 5 equations. The total number of bits leaked to the eavesdroppers in the wiretap canal in time intervals tau1 and tau2 is expressed by the following equation in 8 equations. Okay, the number of bits reaching the eavesdroppers during tau3 is as follows. As you can see, 9 equation. Equation 9. The secrecy rate for the proposed system model is expressed as follows. Equation 10. In this equation, secrecy canal capacity is equal to the total transmitted bits on main canal minus the bits leaked on the wiretap canal. And the energy efficiency of the system model is given by the following equation. Energy efficiency is equal to secrecy channel capacity divided the total energy at relay 1 and relay 2. The optimization problem for the system model is presented below. We aim to maximize energy efficiency under the backscatter reflection coefficients and times variables. As you can see in this optimization problem has the several constraints. For example, first and second constraints are related to the quality of service. In the same way, channel capacity threshold 1 represents the minimum number of bits that must be delivered to the gateway during the time intervals tau1 and tau2. Capacity threshold sub 2 represent the minimum number of bits that must be delivered to the gateway during the time interval tau3. Okay, next slide. Simulation results in figure 2 shows how energy changes with the jammer power. When the jammer power increases, energy efficiency first goes up and then goes down. So the curve has one peak. At low and medium jammer power, the jammer helps by reducing the eavesdropper's capacity and also increasing the energy harvested by the relays. But at high jammer power, the energy cost becomes too large and energy efficiency decreases. If the eavesdropper has a stronger canal, all curves move downward, giving lower energy efficiency for the same jammer power. Overall, the graph tells us that there is an optimal jammer power for the best energy efficient. This figure in this figure 3 shows that energy efficient goes down as a noise power increases. This happens because noise reduces the SNR, and when SNR drops, the capacity also decreases. When the transmit power is higher, the curve is more upward because SNR gets better, but the improvement is limited Since high transmit power also increases the total energy consumption of the relays. In high noise regions, all curves go down to very low energy efficiency. In low noise regions, the decrease is much sharper. Okay, next slide. In figure 4 shows how the reflection coefficient affects energy efficiency. Energy efficient increases when alpha is small, reaches the maximum around alpha between, as you can see, 0.2 and 0.3, and then decreases. As alpha becomes larger, the legitimate link or main link gets stronger, but the leakage to the eavesdropper and the energy consumed by the relays also increases. After a certain point, these negative effects became stronger than the benefits, so energy efficiency goes down. We also see that sweeping alpha 1 gives higher energy efficient because the first user has a high power limit than the second one. Okay, the next graphic, figure 5 shows the Pareto curve between secrecy rate and total energy. As the total energy increases, the secrecy rate also increases, but with smaller and smaller gains. Higher transmitter power shifts the whole curve upward because the legitimate SNR became stronger. The curve stops on the right side because there is a limit on the maximum feasible energy for each transmitter power. And beyond this limit, no solution satisfies the time, quality of service, and power constraint and at the same time. So each curve ends at the highest possible energy and the corresponding maximum secrecy rate. Overall, the graph shows the trade-off: more energy improves secrecy, but the improvement slowly approach saturation. Okay, thank you very much for listening. If you have a question, I will be happy to answer.
Okay, thank you. Are there any questions? Okay, let's go on with the next paper. The title of the paper is Air Quality Forecast with Deep Learning Models Processing.
Hello, I'm sharing my screen.
Okay.
Everything looks good?
Yes, you can start.
Dear colleagues, my name is Marko Bochvarov, and today I'll be presenting a report about air quality forecast with deep learning and models processing. In the next few minutes, I'll walk you through our comparative study of two models, a bidirectional simple RNN recurring neural network model and a bidirectional long short-term memory model, which both were used for predicting hourly PM10 concentrations. Air pollution is still a major global problem. PM10, which is particulate matter that is less than 10 micrometers in size, is one of the most dangerous pollutants. It penetrates deep into the lungs and is linked to heart disease, respiratory issues, and premature death. While PM 2.5, which is particulate matter less than 2.5 micrometers, forecasting is well studied, direct RNN and LSTM comparisons for PM10 particulates are rare. And this is where our work fills a gap. We built and compared two models, a bidirectional simple RNN and a bidirectional LSTM model using real hourly data from Veles, a city in North Macedonia. As for the methodology and data collection, I'll start with the models. So we had two models, which was the simple RNN and the LSTM. These models are classics for processing time series and text. The simple RNN processes data step by step using the current input and a hidden state from the previous step, while LSTM is an upgraded RNN, so it's still a recurring neural network, but It keeps two internal states, a short-term and a long-term. These are the cell states. It has three gates for get, input, and output, and these gates let LSTM decide what to remember or discard. This is perfect for long-term air quality pattern recognition that spans days or weeks. As for the collection of data, our dataset comes from one monitoring station southwest of Veles, which is located in North Macedonia, right next to a busy regional road. The data consists of hourly PM10 values, plus we added 4 weather variables, which were temperature, humidity, wind speed, and wind direction. We took the raw PM10 data, and it initially had a lot of missing values. We split this data by months, and then drop years with too many non-variables, which are basically empty values. Out of this, after cleaning the data, we lost about 26.32% of the original 19 years. And for training, we only kept January, since this was the only month that had the least amount of missing values, and it would give us the most accurate results. All numeric features were rounded up to 2 decimal places, and we encoded a cyclic time with sine, cosine, hour, day of the week, and wind direction. As for the model architecture, both models are bidirectional and process 24-hour sequences. Those sequences have 13 features, which is the PM10, the time encodings, plus all of the weather features. By testing numerous settings and choosing the ones that gave the best results, we arrived at these parameters that you can see on the slide. The LSTM version is similar to the simple RNN layer, where we replaced where the RNN has been replaced by an LSTM layer, and we used RMS prop with a learning rate of 1e minus 4 and a gradient clipping of 0.5. As for the training process, we split the data into 80% for training and 20% for validation. We made sure to shuffle it with a random state, and we trained the model for a maximum of 500 epochs with a batch size of 8. So it doesn't go over some variables, and it doesn't give us issues. We had early stopping with a MAE, which is a mean absolute error validation, meaning that when the absolute error level stopped changing after a few epochs, we picked the best scenario in the past or the best epoch in the past, and based on that, we saved a .curry's file, which we later used for predicting the PM10 values. As for the results we obtained from using the model to predict values for January 2024 were the following. The simple RNN had a mean absolute error of 11.61 micrograms per cubic meter of air. This means on average it was wrong by 11.61 points, with a maximum error of 178.26 micrograms. The LSTM model, on the other hand, had a MAE of 10.9 micrograms per cubic air, with a maximum error of 119 micrograms per cubic air. So the LSTM model was slightly better on both metrics, but both were pretty bad with huge errors for the hourly predictions. And there is a reason for this that will come into the next slide. As we can see on the prediction, this is a 4-hour period. So we had a 1-hour period, a 4-hour, and an 8-hour period. There is a huge error that got us a little bit confused. This error usually happens every single year on the 5th and 6th of January. The 5th and 6th of January, for us in Macedonia, we celebrate an Orthodox holiday or tradition called Kolede, where traditionally people would burn wood, but nowadays they burn toxic materials and plastics the night before Badnik. This creates an unusual spike in PM10 particles that can reach up to 446 micrograms per cubic meter of air. And this can be very, very bad for the model. On the 4-hour, which is a little bit interesting, on the 4-hour period, we saw that the error did drop a little bit for the RNN and for the LSTM. The RNN MAE went to 9.37 micrograms and the LSTM went to 8.96. Then when we go to the 8-hour interval, we can see that the error dropped off even more. The model made only an error of 2.81 micrograms per cubic meter, and for the RNN model, and 1.87 micrograms per cubic meter for the LSTM model. Now, This Orthodox holiday caused a huge spike. So when the values were normalized and everything lowered, it obviously artificially reduced the Maya. This isn't very realistic. Besides this issue, we found that LSTM models beats RNN model on every metric and prediction window. This is to be expected. Lower mean absolute, we have a lower mean absolute error and a much lower max error. So the max error for the LSTM was 119, and for the RNN it was 178. In conclusion, we can find that both models do work for predicting, but the LSTM type of model is a clear winner for PN10 forecasting. Weather variables and cyclic encodings are essential, and the data quality is one thing that matters the most. Outliers like holiday must be handled explicitly, meaning that if your data is wrong and there's issues in the data, the algorithm or the model will not be able to read the patterns and predict the proper outcome. It is also very important to have multiple measuring stations to be able to get a clearer picture. Currently, in my country, we have only one weather station per city, if that, and this doesn't really paint a clear picture because of the differences in areas and how traffic goes and how winds change. As for future work, we plan to add dynamic outlier caps, reintroduce legged features with better imputation, expand to multiple months and stations, and test hybrid architectures and other machine learning models. So that's it. Thank you for your attention. I'll be happy to answer any of your questions.
Okay, thank you. Are there any questions? Okay, let's go with the next paper. The title of the paper is Management of Smart Technology Systems in Conditions of Increased Requirements for Information Security.
Here. Can I share screen?
Yes.
You can see. No,
Mm,
no, you can see.
loading. Yes, now we can see.
Can see, yes.
You can start. Oh no, you closed.
Okay, one moment. Okay. Yeah.
Okay, you can start.
Hello. My name is Dmitry Pecheris. I'm a postgraduate student of the Cybersecurity Department of the National Technical University, Kharkiv State Polytechnic University. In my report, I'd like to present the result of our research on management of smart technology systems in conditions of increased requirements for information security. The modern stage of the information society is marked by the rapid adaptation of smart technologies, which have become an essential part of many areas of human activity. Their use spans energy systems, transportation, healthcare industry, agriculture, and urban infrastructure. The idea of smart brings together sensor technologies, automated data collection, artificial intelligence algorithms, and an Internet of Things, and cyber physical system into a single integrated environment. The relevance of the study systems from several case factors. One hand, smart technologies help reduce cost, improve energy efficiency, automate process, and enable infrastructure system to adapt to change in external environments. On the other hand, their complexity and deep integration into critical areas of public life and other vulnerable for cyber attacks and other man-made threats. The changes of future highlighted by the prevalence and distributed management architecture, which complicates real-time synchronization and coordination of actions. The manager of smart technology system shall be viewed within the framework of cyber physical system, which integrate physical components with digital service to enable interactive control and process automation. Unlike traditional information system, CPS inherently integrated management is not limited to data processing, but also involves direct influence on physical process. On this slide, we show the table of contents of main suite of information security of smart systems. The first is adaptability. The adaptability adjusts operation parameters in response to changing conditions. The second, interoperability, which enables the interaction of heterogeneous components. The third concept is remote automated management. Another essential principle is continuity of management process. Smart technologies cannot tolerate interruptions, as downtime may result in substantial losses participability of sectors such as finance and healthcare. Here we show a comparative analysis of smart system management models in the context of cyber threats. The primary objective is to develop methods to ensure not only effective coordination of smart system components, but also their realized to cyber threats. Scientific approach generally focused on two fundamental paradigms: centralized and decentralized management. Each model has its own advantages and limitations, which become particularly significant when considering scenarios involving attacks on information flows or failures in network protocols. Many studies highlight hybrid models, which combine centralized and decentralized principles as the most promising approach. Unreported directions is also the neutralization of detected threats. Such approach includes dynamic reforming of data transmission routers, isolation of affected nodes, automated updating of security policies in response to detected attack. In the practice of smart system, three keys models used: MAC, DAC, and airbag, given the increasing complexity of infrastructure. Hybrid schemes are considered the most promising, as they allow scalable access policies and can be combined with cryptographic mechanisms. Information security acts as a system forming factor in the management of smart technology. Cryptographic methods ensure the protection of communication, authentication, guarantees the validity of user, and access control regulates interaction between system entries. At the same time, the widespread use intelligent system introduces new risk: attack on sensor, compromise of communication channels, and data corruption of energy on transport system can lead a significant economic and social conclusions. This requires the development of management models in which security is integrated into operation and decision-making functions. In the energy sector, smart technology have given rise the concept smart grids, which connect decentralized producers, consumers, and energy storage systems. The primary management risk is to balance energy flows while considering constraints and the security of communication channels as first model. In the transport sector, in key focusing in the implementation of the integrated traffic and logistic management system based on the eventually to everything concept. IoT sensor enabled to switchless and modern infrastructure generate information flows that optimize traffic, licensing, routing, and conclusion of the real time. Its second model. The most complex examples of the smart technology application in critical infrastructure is a smart city management. It's based on the integration of IoT sensors such as video, surveillance, smart lighting, and parking system, edge computing, and cloud platforms. Quantum computers can factor large number and compute decretal logarithms much faster than classic systems, placing most modern crypto systems and risk. For the management of smart technologies, a key task is to ensure the scalability communication channels, sensors, and collector against quantum attacks. This model demonstrates a direct relationship between management efficiency and the level of protection against modern post-quantum threats, which stages is integration of promising management technologies that allow for increased level of stability, reliability, and security of the system. Managers of smart technology considering post-quantum challenges. Those represents a new integrative paradigm. Traditional resource optimization is combined with cybersecurity models and centralized and decentralized approach. Integrating post-quantum methods in these functions allow for real-time adaptive control and provides resilience to next generation threats. In conclusion, as a result of the research, a set of issues in relation to the management of critical infrastructure system and implementation of innovative protection approaches was examined. The study of theoretical fundamentals allowed for the identification of fundamental principles, government, and functionality of such systems. The determination of the role of management models and approaches ensuring the stability and the establishment of a basis for future analysis of practice aspect. In the context of smart technology, it was demonstrated that modern information and communication solution significantly transform management approaches. The integration of sensor networks, IO platforms, edge computing, and artificial intelligence system creates a new management paradigm focused on the decentralization, autonomy, and enhanced adaptability. Thank you for attention. If anyone have question, I'd be glad to answer.
Okay, thank you. Are there any questions? Okay, let's go with the next paper. The title of the paper is TRVLM, a Turkish visual language model for captioning and visual question answering.
Okay, I am opening the PowerPoint.
Okay.
Can you see the presentation?
Yes, you can start.
No? Okay. Good afternoon. I will make the presentation today. I am Cihan Denizekis from Ankara University. And I am delighted to present our work on TRVLM, a Turkish visual language model for captioning and visual question answering. This research represents a collaborative effort between Ankara University and BTS Defense System. I would like to acknowledge my co-authors, Berkan Bucak and Meceniklioglu Melike Akta, Professor Dr. Gazi Erkan Bostancı, and Ali Berkol. Let me begin with our motivation. Multimodal AI has become crucial for modern applications, enabling image captioning, vision question answering, and cross-modal retrieval. These technologies are transforming how we interact with visual information. However, we have a significant challenge. Current vision language model training is overwhelmingly English centric, creating a substantial barrier for Turkish language applications. This isn't just a minor inconvenience, it is fundamental limitation. Proposed model TR-VLM. Here's our solution. TR-VLM, a model specifically designed for Turkish vision language understanding. Let me highlight its three core capabilities. First, for image captioning. TR-VLM generates both concise summaries and detailed descriptions of images in fluent Turkish. This dual capabilities is crucial. Sometimes users need quick summaries, other times they require comprehensive descriptions. Second, for visual question answering, the model provides contextually appropriate Turkish response to question about the image. The third, and perhaps most importantly, TerraVLM achieves true multimodal understanding by seamlessly integrating visual perception with Turkish language generation. The model combines a frozen SIGLIP image encoder with a Turkish Llama decoder through a learnable projection layer. Our methodology follows a three-phase approach, each building upon the previous to create a robust system. We begin with foundational feature alignment. This initial phase establishes a core understanding between visual input and Turkish linguistic features. We pre-train the model on extensive Turkish image caption pairs, creating a robust cross-modal mapping that serves as the foundation for all subsequent capabilities. The next comes the multitask generalization. Following alignment, the model undergoes fine-tuning across a spectrum of visual language tasks. This phase encompasses short captioning, long descriptor generation, and visual question answering. This broad training allows TerraVLM to develop versatile capabilities and adaptability across different use cases. The final phase, task-specific inference optimization. Here we employ parameter-efficient technique like LoRa adaptation to refine the model's behavior. For instance, we specifically address the tendency toward excessive verbosity in short captions, ensuring the model can produce concise outputs when needed. Now examine our architecture in detail. As shown in figure 1, the system comprises three interconnected components. Starting with SIGLIP vision encoder, the process 224 by 224 pixel images, dividing them into 196 patches. Each patch between becomes a token with 786 dimensional embeddings that capture both spatial and semantic features. We choose SIGLIP for its proven robustness and efficiency in multilingual context. The crucial innovation lies in our projection layer. This component transforms 768 dimensional visual embeddings into the 4096 dimensional language space. It's not just dimension matching, it's bridging the fundamental gap between visual and linguistic modalities through an intelligent token replacement mechanism. Finally, Turkish Llama serves as a language decoder. It generates Turkish text using causal self-attention over the unified visual textual sequence. We enhanced it with an updated tokenizer that recognizes spatial visual tokens, enabling seamless integration of image features. The elegance of this architecture lies in the efficiency. By keeping the encoder and decoder frozen during initial training, we preserve their pre-training capabilities while learning only the cross-modal alignment. This dramatically reduces computational requirements while maintaining the high performance. Uh, Next slide is dataset. Quality data is backbone of our system. We assembled comprehensive datasets for each training phase, as illustrated in figure 2, 3, and 4. Our pre-training dataset consists of 575,000 Turkish captions pairs sourced from PD12M and Flickr 30K and other created repositories. This provides the foundational feature alignment between visual and linguistic modalities. For fine-tuning, we compiled 735,000 examples across the three categories: visual question answering, Turkish translation of COCO, GQA, and visual genome, short captioning under 20 words, and long description exceeding 30 words. This diversity ensures the model can handle various interaction styles. Additionally, we created a specialized dataset of 510,000 short captions for targeted fine-tuning. This addressed the model's initial tendency toward verbose outputs with careful designed prompt-driven examples that teach conciseness. All datasets have been created and publicly available. Training strategy and inference strategy, or training strategy, consists of three orchestrated phases. The pre-training phase establishes foundational cross-alignment. We freeze both SIGLIP and LLaMA training only the projection layer on 575,000 caption pairs. This focused approach preserves the pre-training knowledge while learning the visual language mapping efficiently. Multitask fine-tuning builds generalization across diverse tasks. Using LoRa adaptation on 735,000 mixed examples covering VQA and various caption types, we achieve remarkably efficiently. Only 0.31% of parameters are trainable, yet the model develops broad task flexibility. The short caption fine-tuning phase corrects the verbose output bias we discovered during evolution through targeted LoRa training on 510,000 concise captions. We enable the model to produce appropriately brief outputs. For inference, we implemented two key innovations. First, with dynamic checkpoint selection, the model automatically selects the optimal checkpoint based on input prompts and context. Second, prompt-based task switching. User intent expressing in natural language triggers dynamic LoRa module switching. When users request brief description, the short caption model loads. For other tasks, multitask model handles the request. This adaptive framework ensures the model responds appropriately to user needs without manual intervention. Let me briefly cover experimental methodology. We evaluated on 4 Turkish datasets: Flickr 8K, Turkish for short captioning, Turkish VLM mix for long description, or custom VQA test set, and multitask evaluation suite. All experiments were conducted on a single NVIDIA A100 GPU via Google Colab, demonstrating that our approach is accessible to researchers with limited computational resource. Our evolution employs comprehensive metrics. We use ROC scores at different levels, BLUE and Meteor for assessing n-gram overlap and surface level similarity. BERT score provides semantic similarities through precision, recall, and F1 measurement. Additionally, we conduct human alignment studies using GPT-4o as a judge on 100 randomly selected samples, evaluating instruction compliance, visual consistency, semantic accuracy, and creative diversity. results. Our results demonstrate strong performance all tasks with particularly impressive result for short captioning. Looking at the metric table, short captioning achieves the highest score across the board, ROOM1 of 48.16%, Meteor of 29.16%, and crucially a BERT score F1 of 66.87%. These metrics confirm that the model generates concise and semantically accurate captions. Visual question answering shows robust performance with BERT score F1 of 64.62% and ROOM1 of 35.33%, indicating accurate comprehension and response generation. Long captioning presents more challenges with BERT score F1 of 54.93%, highlighting the inherent difficulty of maintaining coherence in extended narratives, an area for future improvement. The multitask configuration demonstrates a balanced approach across all metrics, validating our unified training approach rather than developing separate task-specific models. These quantitative results confirms that TR-VLM successfully bridges the gap in Turkish visual language understanding. Beyond automatic metrics, human-aligned evaluation provides a crucial insight into real-world usability. Our GPT-4o Judge study assessed for K dimension on 100 random samples. Visual consistency scored highs at 73%, demonstrating strong agreement between generated text and visual content. The model accurately describes what it sees. Semantic accuracy reached 68%, confirming faithful meaning preservation with minimal hallucination. Instruction compliance achieved 63%, showing the models follows users' constraints reasonably well, with room for improvement, of course. Creativity and diversity scored 55% or lowest metric, indicating that while outputs are accurate, they could benefit from more stylish variety. These human-aligned scores corroborate our automatic metrics. TR-VLM excels at semantic grounding and visual understanding, but could enhance its creative expression. Let me conclude by emphasizing our three key contributions to Turkish multimodal AI. First, we introduced a compact, efficient architecture that couples Siglip with Turkish Llama via learnable projection layer. This design is specifically tailored for low-resource Turkish contexts, making advanced AI accessible for broader community. Second, we created and publicly released comprehensive task-balanced Turkish dataset, short and long captioning, and plus VQA. This addresses the critical data scarcity that has limited Turkish AI development. Third, we demonstrated a remarkably efficient training strategy using LoRa and prompt-contained checkpoint, achieving a strong performance with only 0.31% trainable parameters. Proves that effectively AI doesn't require massive computational resources. While challenges remain, particularly with long-form caption generation or evolution, including GPT-4o human-aligned score, confirms that TR-VLM follows instructions well and produces semantically accurate outputs. TR-VLM represents a foundational step towards native Turkish multimodal AI. Future work will focus on expanding dataset, improving instructions, tuning, and enchanting long text generation capabilities. Our model, dataset, and code are publicly available, and we hope this work catalyze further advancement in Turkish visual language understanding. Thank you for attention. I'm grateful for this opportunity.
Okay,
I
thank
welcome-
you. Are there any questions? Okay, let's go with the next paper. The title of the paper is Designing an Android Application for Accelerating Food Delivery Pickups.
Okay. Hi, can you hear me?
Yes.
Hi. Sorry about the delay, by the way. I couldn't attend this related time, and I'm sorry about that delay.
Okay.
And thank you very
No
much.
problem. You can share your
Um,
screen.
yes. All right. Hi, everyone. My name is Aner. Today, I would like to talk about designing an Android application user interface for accelerating food delivery pickups for you. This is based on a real problem that most of the food deliveries are kind of very delayed and also late during the pickup after the food order has been participated in the locations, mostly United States. But also this work contains the other locations like Australia, Europe, Asia, or like how do you order food for the deliveries for yourself or something else. Our work is mostly focused on interface development with Android ecosystem. It's also possible for Apple or other mobile platforms. But for this work, our target is mostly Android and Java-based application development. This study represents the design and development of an Android application aimed at improving the efficiency of food delivery pickups. The proposed system reduces waiting times by helping delivery drivers get noticed faster at restaurants. And developed using Java in Android Studio, the app streamlines notifications and minimizes distractions to improve delivery speed and customer satisfaction. The food delivery market continues to grow in the United States, and the popular platforms are DoorDash, Uber Eats, GrabUp, and Instacart. And the problem is the delayed order pickups at restaurants. That causes a huge delay during the food preparation and the food delivery. As a result, customers are receiving their orders very late. And the objective is enable delivery drivers to be noticed faster and improve delivery efficiency during the prime time and also busy times. This application found very useful. And the first one is the order lifetime. So this is customers who wanted to order something for themselves. A customer places an order and delivery app sends this order to the restaurant, and then delivery driver is found by the application, and the pickup is confirmed, then order is delivered. So we have got 5 steps, most major 5 steps that makes the food delivery possible. The problem arises at step 4, delayed pickup. So this work is focusing on step 4 because the pickup is most of the time late. And there are some metrics that describing why or how those pickups are late to the customer side. And this app helps reducing this delay by making drivers more noticeable. So according to this chart, we have got 5 steps. We have got customer, restaurant, delivery driver, and the delivery app is over here that's taking place and making an affection into this order lifetime. So as we said, customer is in step 1, is now using their own application. Any of the commercial application can be used for this task. So they order something for themselves for their needs or for their convenience, and then they use their delivery apps. And then those delivery apps are sending the orders to the restaurants, and restaurant or any kind of convenience store or some shop, and then the restaurant need to find someone to deliver order to the customer. So there should be another third party application such as DoorDash, Uber Eats, Grubhub, and any other locations or the regions that might be different by the names. And this delivery app is also installed with delivery driver because they need to follow what's the customer name. So what is the content should be, and what distance they need to drive and drop off their order. And in the end, delivery driver confirms when they reach out to the customer's location at step 5 over here. And then customer is also giving some feedback maybe to restaurant or maybe to the delivery application, whether they have some problem or they received the order with no problem. And then this order cycle completes. So this is a mobile order life cycle of the delivery system. So this application design of this work and the study, the main screen allows entering customer name and adding emojis. Full screen display helps drivers show their details to staff. Design reduces unnecessary dialogue and improves communication. Built using XML for Java for functionality. And then we created a new application called Delivery Text. Delivery Text, the mobile application to help delivery drivers to pick up their orders faster than they used to do. So this is the main screen of our mobile application. The main screen page of this Android application is now you are showing the screenshot, and later on I will show you a live testing screen by connecting my phone for proof of concept. So on this main screen, you may see the delivery text as a toolbar on the top, and then the application is requiring you to insert your customer name. So over here, when you insert your customer name, maybe by shrinking or giving just a first name, or maybe just last name, or just initials as, for example, O.Y. To keep the privacy, it's really up to the driver. Like, how do you want to communicate with the restaurant or the pickup location with your customer name to mention the order pickup? And then if it's needed, or if you want to make add any joy, you can add some emojis like a burger, fries, drink. And if there is a drink in the order, because most of the time we detected that, and also customers are reported that drinks are missing from the orders. If you order some burger, delivery driver maybe forget it in their car, or maybe the restaurant didn't provide the drink, or external items that belong to the order is missing. And also for breakfast, some burritos or other products, as you can see, for supporting your order details, because delivery drivers know most of the time what's inside of the order. And then delivery driver clicks on this button, show on full screen, and then the customer name will appear as a full screen. And over here, there is another button, says show only text, which means that this application can go full screen with no toolbar, no buttons, just a customer name without any other components. On the full screen, we have got timer, but show only text doesn't have a timer. For example, when a delivery driver enters into a restaurant, show on the text button will not show the timer countdown, like how long do they been waiting in the restaurant is missing here. But on the first button, which is greater than the other button by the size, allows you to provide more details and also more components. And there's a user interface introduction with a describing of what is delivery text, and then the questions and the reachable metrics. So when delivery driver enters into the restaurant or pickup location, they use their mobile phone screen, and they show the customer's name with some necessary, or I mean, it's very optional onto the screen. For example, my name is Honor, and assume that I'm a delivery driver. I'm now entering a restaurant or a pickup location for my customer for a delivery pickup, and then I'm showing my customer name full screen, and you just see order 4 on the top left corner, and in the middle you will see the 00.00 as a time. This is timer countdown. For example, like how many seconds or minutes that I've been waiting for this order can be counted here. And then there's the advertisement section on the top right. And over here, all on the full screen from bottom left to the bottom right corner, this is our customer with some emojis for, color for emojis instead of a black text color of the customer name. So showing the customer's name on the full screen of the second activity as order for honor provides easy and faster order pickups. And I wanted to create some proof of concept. This is AI generated images of two images available on this slide by Google Gemini. So before, there might be another delivery drivers in the restaurant or the pickup location. It's most of the time busy with the prime time. For example, after 4 o'clock, till 9 o'clock p.m. We call as prime time because everybody wanted to have dinner on their own or with someone. They wanted to order some food or maybe some necessary products like dog food or cat food as well. And they use their mobile application to order. And delivery drivers are over here in the responsibility to deliver those foods or their the customer's order from the restaurants to pick them up. So on the second picture, you can see order for honor can be shown by the delivery driver from far to the restaurant workers, and then they will notice you from far because in the United States, people might not speak English very well because there are some other languages that you can hear in the regular time of the street. For example, Spanish is very well known in the United States, and Portuguese is also spoken here, French and Italian. We have got so many languages in our daily life that we may hear. So, and everyone's name is a little bit different to pronunciate. For example, my name is in Turkish Onur, but in English it's Honor. So sometimes it creates a difference whether you write and whether you read. So as long as the reading is different than you write by the other cultures and the other languages, it creates a problem. So main problem on this work is to write the customer name on somewhere like a paper, or for this work, it's gonna be the mobile phone. Because mobile phones are a great way to show the customer with the illumination because the background is illuminated and you can get noticed from far easily. Actually, this is a very good idea because delivery drivers are most of the time waiting for the delivery pickups in the store by, in the quotation, doom scrolling in Instagram or TikTok or somewhere to take, passing the time for a little bit leisure. But they need to focus on the food delivery, whether it's ready or not, because most of the delivery drivers are waiting in the line or maybe outside of the line. Even though the order has been prepared by the restaurant worker, but due to the business and also other upcoming tasks that restaurant workers need to take care and handle, they most of the time forget that food has been prepared already and the delivery drivers didn't notice this. So if our delivery drivers need to show their customer name like this on the second image, they will follow their foods instead of doom scrolling. So if instead of spending some time on the internet during your wait, it's very good idea, and also in the results, it's very successfully increasing the speed of order pickups, because even though you came restaurant after the other delivery drivers that already been inside and waiting for the other orders for the other customers, a delivery driver who is using delivery text application found very faster to pick up the order among the other delivery drivers. So even though you are late to enter, your order can be prepared a little bit faster than the others because the restaurant workers can easily read their names and whom are you responsible to pick up the order for? For your customer. So image for the problem statement is a chaotic and busy restaurant counter with several delivery drivers looking confused, some on their phones trying to get attention from overwhelmed staff. This highlights the latency at a pickup. And image for the solution, the app in action on the right, A delivery driver holding up a phone with a very clear, large display of a customer's name, like John Doe, to a restaurant staff member who instantly recognizes it and points to a ready order. This contrasts with the previous image showing efficiency. And in terms of materials and methods, the platform is Android chosen over iOS for cost efficiency and also proof of concept and building the new application by the standard. And the development tools over here is Android Studio with Java and also XML for the interface for the user. And device testing is Android tablet and smartphones with SIM cards, and maybe not necessarily the SIM card, but also we tested with the Android tablets because most of the time you would like to pick up your order more than one customers. And if you have, for example, if you have 5 customers for the pickup from the one store, you may need an Android tablet for the wide screen to showing your customer's name and receiving your orders. So the focus is improve visibility of delivery drivers during order pickup. The
Sorry,
results are
your time is finished. Please try to summarize and conclude.
okay. The results are improved communication between drivers and restaurant staff, reduced wait times observed in pilot tests, and application improves workflow efficiency and driver focus, and Delivery Takes app facilitates faster orders handovers. And in the conclusion, delivery drivers can accelerate order pickups by using their phone screens to display customer names and reduces miscommunication and waiting times and enhance driver efficiency and customer satisfaction. Also, discussions are available for this work. The acknowledge is over here. And before, I mean, if I have 1 minute or less, I need to show you my real-time usage for it very quick. So this is the real application. Over here on the customer name, assume that you are waiting for Jack T, and if your order has a pizza, you go on full screen, and application is changing the direction of your mobile phone from vertical to horizontal, and now the counter begin. This is showing you how long you've been waiting in the store and your customer name with a related emoji. So order for Jack T can be seen from the restaurant worker from far, and you can even no longer talk or ask about or show your phone screen to the restaurant worker in the short distance. Instead, if you are deaf and if you have some talking disability, this is a great way to pick up your order. Thank you very much.
Good, thank you. Do you have any questions, dear participants? Okay, let's go with the next paper. The title of the paper is Customer Perceptions of Humanoid Hairdresser Robot, a Focus Group Evolution and Machine Learning Analysis.
Yes, hello. Is my voice clear?
Yes, you can share your screen.
Hocam, let's share my screen, please. Yes. Can you see my screen?
Yes, you can start.
Okay, thank you very much. Hello, dear researcher and the respected meeting chairperson, Dr. Ojan. Hopefully I pronounce your name correctly. If not, accept my apology. Hope you are
No
great.
problem.
Thank you very much. Hope you are great. My name is Mohammed, Assistant Professor in Marketing Department, Nearest University, Cyprus. I would like to say appreciation to management for all efforts they put for arranging this great conference to meet each other and sharing our research outcomes. Let's begin with where my idea come from. As you can see, the topic, and as Dr. Ojan mentioned it, my topic is customer perception of humanoid hairdresser robot using 2 different techniques, a focus group and machine learning analysis. I've been working in beauty industry for many years, and my concern has always been how to increase the quality of relationship between service provider and customer in this important sector. So let's start. Are you in the second slide, right? Just a confirmation.
Yeah, it says the introduction.
Yes, absolutely correct. Thank you very much. I went through the literature and I tried to understand how the new services or even the old services take advantages of the advancement in AI and robotic. And I realized that many service businesses, they use AI and robotic in order to deliver their services to the customers. It can be product or service, but specifically I focus on the service industry. There are many benefits according to my research that they can be efficiency, consistency, cost reduction, and enhance the customer experience while they're delivering the service and business to their customers. However, I couldn't find any unique research that try to address high contact services such as hairdressing service. You know, there is a difference between hairdressing services or beautician as a service provider compared to other services, and is that a person, a customer, normally used to visit the hairdresser as a service provider higher than the other service deliveries. That's important of this industry. That's why I focus on this industry for many years. Let's look at the human role in hairdressing. Hairdressers provide not only technical skills like cutting, styling, coloring, dyeing hairs, or so on, but also empathy, trust building, emotional connection or communication, and aesthetics judgment. So customers often develop their habitual behavior and relational bonds with their hairdresser, which might be difficult to create such these things using or hiring the robots in this industry. That's the main concern. So let's talk about why hairdressing is different. I mentioned some of them. But the thing is that existing research focus on robotic services in hotel, restaurant, healthcare, retail. Uh, Actually, they are significant if you Google it, and they're all about the services that the connection or communication between service provider and the customer are not that much compared to the service provider, which is beautician or hairdresser with the clients. And we have three main challenges here that I list them. The first challenge is the need for warmth, empathy, and creativity, which we need in the beauty industry. And physical closeness and emotional trust during the service, very important, even more than hotels, restaurants, and healthcare industries. And also the impact of two important phenomena, which we call them anthropomorphism and uncanny valley. These are the reaction of the customers when they see a robot or a or close face or close or similar face to humans. I mean, the AI, it can be AI, it can be robots or anything. The customer, they have different attributes in order to accept this technology or not. So it was my main concern in this study. So the thing is that in order to address these gaps, we have some objectives from this study: explore customer perception of humanoid robots, identify expectation, concern, and emotional reactions, and robot design appearance and behavior that shape acceptance and trust using two different techniques, a focus group and also the machine learning. For this study, first I start conducting a focus group because it's the first time. So I start with the qualitative research approach in order to understand the customer perception and going through more details about their perception and attitudes. I choose students in my class, 12 students, Generation Z. Why Generation Z? Because they are innovation oriented, familiar with AI, and they really care about social aspect of the service. And most of the participants, or better to say, all of them, they were chosen based off their visit frequency of their hairdressers. And I choose those students who visit the hairdressers more than 12 times per year to increase the accuracy of the result. And then I choose dual moderator focus group in order to extract the ideas of participants. The most important part of my research was actually which robot is the best to choose to show the high level of similar face to human beings. I choose this famous robot AMECA, AMEJA or AMECA, is the famous and is used in the other studies as well. I play this a video, official video, commercial one, to my participant. Then we start discussion regarding to this person. And the discussion topic, I use person, actually is a robot. The discussion topic mainly was about trust, advantage, concern, expectation of robotic hairdressers. Then I used three analytical techniques: thematic, sentiment analysis, and topic modeling, LDA. I'm not expert in machine learning. My co-author did it. Let's go to the stages. I have been through 4 stages to get the result. One was transcription and organization. The focus group lasts 18 minutes. And we try to listen to record what we recorded before. We try to label them manually, then we manually coding them. Then we try to refine the data, those concern or those labels that they didn't mention too much across participants have been removed from the study. And then we choose the rest of the concern or comments or transcripts for the machine learning analysis. According to the results, 70% of the participants or the discussion mainly focus, or the result shows that they were negative. They show a negative reaction towards these robots if they want to choose it as a hairdresser in future. 25% positive and 5% neutral. So it shows that while some technical benefits were acknowledged, like precision, speed, improved hygiene, these benefits did not unweight emotional concern. So mainly they care about the emotional things, the emotional connection between themselves and the hairdresser in the future. Also, if I go to another slide, is the result of LDA. As you can see, dominant themes identified as a human touch and empathy, 30%, creativity and personalization, 25%, robotic appearance, 20%, efficiency and precision, 50%, and novelty and hygiene, 10%. Again, the highest weight themes related to relational, emotional, and aesthetics aspect of hairdressing, not only the, let's say, the technical things that a robot can deliver to them. And if I want to go through the details, these are the most frequent negative themes and positive themes. Let's quickly review the result. Lack of human touch, 38 times mentioned in the discussion. Emotional discomfort, 32%. Lose of creativity, 28%. Robot appearance concern, because each and every time that you want to go to see your hairdresser, you will see a robot without any change in the appearance, so it will be boring for you or for the customers. This is, I mean, this sentence, robot appearance concern, is related to that one. The customer doesn't like to see the same service provider with same style, same voice tone, or maybe the appearance and the body physics and such these things. They need to see different styles from the same hairdresser each time that they visit them. Let's look at the positive themes that they highlighted: consistency and precision, 15 times mentions, efficiency and speed, 12 mentions, and all AI-driven customization, 10 times mentioned in the discussion. So let's summarize what we've done and look at the discussion, look at the result from 4 different perspectives. Customer reactions. As we discussed, predominantly negative response we received from this research. Participants value empathy, creativity, trust, and personalization more than efficiency or precision. from the TM perspective, TM is theory of acceptance model. Technical usefulness acknowledged, but emotional and statistics usefulness, they were in doubt. They're not sure that whether they would accept it in the real life or not. Let's look at the policy implication. Need regulation for job displacement, safety, and data privacy specifically. Policymakers must balance efficiency with preserving the human touch. Let's look at the marketing side, marketing implication. Robot substitution may reduce customer engagement, loyalty, and customer citizenship behavior, potentially harming business performance according to this research and what we got from or the result. Limitation, like the other research, also my research has some limitation, of course. A small sample size, as you know, it was focus group at the beginning, so only 12 students from the generation Z. We can extend this research to the other generation, let's say, X, maybe generation Alpha in future. They are very, very critical generations that we should focus on in the future. And let's look at the second limitation, not real interaction. As I told you, I choose a robot and I show them a video, a commercial video. Maybe if they face a real robot in the real life, maybe the attitudes they'll change or the perception might change. It must be also test in the industry. However, we don't have any robot cutting hairs specifically for in this industry. And let's see another limitation, dependence on the manual coding. As I told you, and in order to code or labeling, use a researcher, and also I involved in this process. So it's better to use machine learning, better and more efficient in order to use the coding to coding these texts. And future research needs to address a quantitative study because it was qualitative. Now we have a theory. After the theory, we can go to the quantitative study. And hopefully one day we can do these tests when we have a robot in this industry, and also a longitudinal study to track the acceptance over the time. So it was a video clip, as I told you. In the future, we should test it in the real life when the customer experience this robot over and over, not only once. Thank you very much. If there is any question, I would be happy to answer if there is any.
Okay, thank you. Dear participants, do you have any questions? Okay, let's go on with the last paper. The title of the paper is Improving Environmental Degradation Prediction Using Meteoristic-Driven Machine Learning Technique.
Good afternoon.
You can share your screen.
All right. I hope you can see my screen now.
It's loading. Yes, we can see.
Okay, thank you. Good afternoon, everyone. My name is Dr. Oluwatayomi Adigboye. I'm here to present my research titled Hybrid Optimization Framework for Load Capacity Factor Prediction. And
sorry. What's your paper ID, by the way? Is it 47?
Yes.
The title is different, I think, in the program.
It's the same.
It says improving environmental degradation prediction using meteoristic-driven machine learning technique. Is it correct?
Yes, it's correct.
Okay.
All right. So we all know that climate change is a worldwide crisis that has manifested in harsh weather condition, biodiversity loss, natural disaster, and economic disruption. And there has been a need for accurate models that can be tools for predicting indicators of these climatic conditions, and also to be able to develop effective policies. And although CO2 has been largely used to as a indicator to predict atmospheric pollution, degradation, water pollution, and resource depletion, but it's not comprehensive enough. So recently, researchers came up with load capacity factor, which is more comprehensive for sustainability assessment, and it simply is biocapacity divided by ecological footprint. In this research, we try to use multi-layer perceptron, which is largely unexplored in the area of predicting load capacity factor, and also to be able to improve the accuracy of the multi-layer perceptron, we developed an hybrid optimization algorithm, right? That is for though traditional optimization algorithm have limitations with exploring and exploiting the problem effectively. So we try to build an hybrid optimization algorithm. So the major contribution is two key things: to develop an hybrid optimization algorithm that is more effective for optimizing the hyperparameters of the multi-layer perceptron, and also to yield better accuracy. So in the research, we used a Bayes algorithm, that is the polar light optimization algorithm, that is inspired by the Aurora formation. And it has several mechanisms inside to for optimizing a problem. But due to its limitation with exploration and exploitation, we infused it with a more established algorithm, the SAP-SWAMP optimization algorithm, that divides the population into two, then applies two mechanisms, the leader mechanism and the follower mechanism. And we tested on benchmark problems before applying to the multi-layer perceptron problem to improve optimize the parameter of the weight and the bias of the multi-layer perceptron to yield more accurate input. In the initial phase of the algorithm, the polar light optimization algorithm is applied, and afterwards, towards the end of the optimization process, the SAP-SWAMP mechanism is applied, where the population is divided into two. We apply leader mechanism for exploration and follower mechanism for exploitation. And in the search process, the weight and the bias are represented as vectors that contains the weight and the bias of the multi-layer perceptron, and the fitness associated with each particle is the mean square error of the multi-layer perceptron. And at the end of the optimization process, the particle with the least mean square error is actually the most optimal parameter that can then be used to build a final model for prediction. And here in figure 1, you can see a basic illustration of the polar light that use the Aurora walk mechanism for global optimization and the gyration motion for local exploitation. And both are fused together at the end. And in figure 2 is the proposed model itself. Initially, we can see where we calculate the fitness of each particle when they're initialized randomly. And the MSC of the multi-layer perceptron is returned as the fitness of each particle. And afterwards, we apply the mathematical operations of the polar light. And towards the end, like I said earlier, we divided the population into two to apply the SAP-SWAMP optimization algorithm mechanism to improve the search for the optimal solution. And before applying to the problem, we used one of the IEEE benchmark functions, the CEC 2017 function, that comprised of 15 complex problems of unimodal type, multimodal type, hybrid modal type, to test the capacity of the function. Although all the results are not present here, just a sample of them, when we can see that in most cases, when compared to the basic polar light and other algorithms, we had a better result or more improved performance. And also the convergence chart of the hybrid optimization algorithm, we can see that it had more convergence characteristic than its traditional or its basic form. And finally, we applied to the load capacity problem, and we used a data set, a monthly data set from Malaysia from 1970 to 2021. And we got the load capacity factor as the target variable, and we used input variables like oil consumption, agriculture, natural resources, economic growth, which is GDP, and also population growth as input variables to predict the load capacity factor and also to find the impact of each of these variables on load capacity factor. And we got our data from Global Footprint database, British Petroleum, and the World Bank database. And for the training result, where we applied basically 4 metrics, the determinant coefficient, which tells us or gives an estimation of the accuracy of the model, mean square error, mean absolute error, and these are error metrics. So the determinant coefficient tell if it's as high, although the maximum should be 1. It tells us it has more improved accuracy, and the more it goes towards 0 or infinity, we know that there is less error in the prediction. And in the training, we can see that the SAP SWAMP hybrid model has improved accuracy during the training, and also in the test result, we also see that it yielded more improved result than the compared traditional optimization algorithm and the basic MLP. And of course, this is without meaning if we cannot categorically tell which of the factor is actually driving the accuracy or is affecting the accuracy of the model. So finally, we performed a feature importance score, that is a permutation importance score, which we keep the other variables constant, then we permutate one of the variables several times to see how it affect the accuracy of the model. And finally, we found out that from the model, agriculture activities had more impact on load capacity factor in Malaysia. Also, we found out that GDP also had the second highest impact, and finally, oil consumption also is the third most important factor. And these are considerations that can be taken into policy decision making as regarding environmental degradation, specifically for the case study of Malaysia. And a conclusion, the newly developed optimization algorithm with the multi-layer perceptron, we had more improved result. And also we've found out that hybridizing with the SAP-SWAP algorithm also yield more improved exploration and exploitation. Also in tuning the hyperparameters of the multi-layer perceptron, we add more accuracy and also less error. And also we achieved a test accuracy of 95%. Roughly. And here are the limitations of the study. We relied majorly on one data set, which is a limitation in terms of maybe generalizing to more countries. So that's a limitation. And also future work will look at how we can also take more data from more countries to build a more robust system. And also another consideration too is that when applying the optimization algorithm to the multi-layer perceptron, it requires more computing time. So that's also a factor that we would also look at in the future. So thank you so much for your attention.
Okay, thank you for your presentation. Are there any questions? Okay, we have completed all of the presentations. Dear participants, on behalf of organizing committee, I would like to thank you for your scientific contribution to the Congress, and we hope to meet you in next Congresses as well. Now, I'm ending the session. Thank you.
Thank you. Have a nice evening.